Saxon Algebra 1, Lesson 5. Welcome my students to a fresh week of math. If I talked to you last week in a video chat, fabulous. Thank you for making all that work. If I did not connect with you last week, we will try again. This week I'm expanding and rearranging my office hours a little bit. You can check in with me either on Thursday from noon to 5 or on Friday from noon to 5. So that gives you a little bit more flexibility so that some of my students were really jammed up on Fridays. So that gives you another option for when to talk to me. If you did not speak to me last week, that's okay. We don't have to arrange like a makeup or anything. We'll just cover 2 weeks when we connect at the end of this week. I'll remind you when I post lessons post the second batch of lessons later this week. All right, let's dig in. Lesson 5 is, it's a little long, but it's manageable. The first thing we're going to talk about are sets. Sets are a well-defined collection of numbers. I mean, you can have sets of other things, right? Collections are the key word, and we organize numbers in some interesting ways. When you were little, you learned how to count. And we call that set of numbers the natural or the counting numbers. And you learned 1, 2, 3, 4, 5, and on you went, right? Slowly adding numbers, eventually adding the understanding that just went on forever. And that was you learning how to count naturally. I bet there were moments when you and your mom, or maybe your dad or your grandma, sat together after your bath. You were probably wrapped up in a towel, and they probably counted your little fingers and your little toes, and you learned how to count with them. 1, 2, 3, 4. I bet it was super cute. Eventually, you were old enough to understand that before 1, there was this number that meant nothing. You might have first learned it when you put your hand into the cookie jar or reached into the cookie bag and realized they were all gone. There were 0 cookies in the cookie bag. And that's when your little brain exploded with understanding. And as a toddler, you probably understood there's this thing called 0. And it is a powerful number. And then at some point, maybe when you owed somebody some money or they owed you money, you understood there's such a thing as negative numbers. And they extend just as far in the negative area as they do as in the positive area. Every number can be a negative number. I have to put a 3 here. I'm not going to feel good about my life. So these are 3 sets of numbers. There are more that we're going to talk about later, but I just want to introduce these ideas to your vocabulary. Natural numbers, whole numbers, and integers are different sets of numbers that we talk about. Okay, absolute value. Value. Absolute value has a conceptual or a theoretical definition that is a little bit hard for beginning students to wrap their mind around. So I'm not going to waste our time with that. I'm going to be very practical. Here's the way absolute value signs work. There's 2 straight lines like this, and whatever is inside of those signs turns positive. If it's already positive, that's fine. It just stays positive. So it's like a positive maker. That's all it does. If you put a little calculation in here, like that, this says -2 - 3. Well, that's equal to -5, right? And then that, we strip off the minus sign, it's +5. So no matter what number is inside of an absolute value, to simplify it, you just take off the minus sign and throw away the absolute value lines. All right? Here are a couple examples of that to show you what the problem might look like. Whenever I flip the page, I always stand up just to double check and make sure that My book is still centered in the frame, and I'm sitting on a chair. I'm usually sitting on this chair. It's super squeaky. So every time I stand up, the chair squeaks. And I always think, I really should just use a different chair. But here I am, once again, in the squeaky chair. 5.1, simplify A. John's so tricky. Sometimes he does this A, B, and C thing within the problems, and it's kind of cheating. I think it's cheating, John. I'm sorry. All right, these are increasingly complex. Let's practice simplifying them. Okay, the first one. Well, I told you it strips off minus signs, so that it's just positive 5, okay? This one, we have a little calculation to do inside of it. 11 minus 2 is 9, so we want the absolute value of 11 minus 2 is the same as the absolute value of 9, which is the same as just plain 9. Make sense? Now, here's something different. Here's a minus sign outside of the absolute value signs. We treat that just like we do when we have a minus sign over the parentheses, and we look and see, can we cover it up? Is it protected by the absolute value signs, or is it out there exposed like a little lamb in the pasture away from the sheep? I don't know what I'm talking about. Never mind. I cover it up. Now we say, okay, 20 minus 2, that's 18. I'm not going to keep writing it out like this. I'm just going to make notes. 20 minus 2 is 18. Absolute value of 18 is 18. But now I've got a minus sign. So my answer this time is minus 18. And you say to yourself, but wait, you told us that absolute value signs always stripped off the minus sign. Yes, they do if it's inside. But if it's outside, then it does not fall under the jurisdiction of the absolute value. And we put it back on at the end. All right? Cool. All right, last part of this lesson is adding signed numbers. Now, John has this diagram that he likes to use to show signed numbers. He takes a number line, and then he draws these dots and these arrows. If you have used this before, here, let me show you another page. Here it is. He goes crazy with all this, right? I always feel like it's a football play, and he's Pete Carroll, or the offensive coordinator, you know, lining everything up. I don't like that. That drives me crazy. I don't recommend it, and if you understand those and you like to use them, more power to you. But I'm going to tell you a different story. Once upon a time, there was a meadow. And in the middle of the meadow, there was a hole in the ground, all right? So here's the little meadow, the little flowers, little tufts of grass. The sun is shining overhead. Bunnies are hopping. I'm not going to draw bunnies. Bunnies are hopping. Birds are tweeting in the air. And here we are strolling along through the meadow, and we come across this hole. Now, sticking up out of this hole is a ladder. We notice that there's a step right at the ground level of the hole, and then there are steps going down, and there are steps going up. And we notice that it goes infinitely down, and it goes infinitely up too, right? Well, we decide to climb on this ladder. So we jump on and we start climbing. I don't know, do you want to climb up or down first? It doesn't really matter. But what we notice when we start climbing is that on each little step there's a number. The step that is perfectly even with the beginning is 0. And then as you go up, the steps go up 1 digit at a time. As we go down, guess what happens? They also go 1 digit at a time, but they're going into negative numbers. This is what I imagine whenever I am adding or subtracting negative numbers. And by the way, we always just call it adding. Subtracting negative numbers is the same as adding negative numbers. So we just usually say adding signed numbers. When we are combining numbers, we use this ladder to imagine ourselves climbing up and down to combine the numbers. Let me show you an example. Example 5.2. Use directed numbers and the number line. Never mind that, just say use the ladder in the meadow to add plus 3 and, here, I'm just going to write this, add plus 3 and minus 5. So here's what happens. We step onto the ladder at 0. We always start at 0. Now John tells us to go up 3. Okay, 1, 2, 3. We're on step 3. That would make sense, right? Because if we go up 3 steps from 0, that gives us 3. And now we have to go down 5. 1, 2, 3, 4, 5. We end up at negative 2. Does that make sense? So we would say the answer to this is negative 2. And that is correct. Okay, let's try another one. Use, again, John has this expression, use directed numbers in the number line. No, say use the ladder in the meadow to add minus 5 and positive 3. Okay. Add minus 5 and plus 3. So again, we jump on at 0. We go down 5. The minus sign tells us to go down the ladder. 1, 2, 3, 4, 5. That puts us at minus 5. Okay, that makes sense. And positive 3. That means we go 3 up. 1, 2, 3. So that's negative 2 again. Funny how that turned out, huh? All right. Later, we're going to develop some rules that will allow us to do these problems a little bit quicker. We won't have to step around on this. Remember, though, that this is like a board game where we start on 0, and then if we're going down 5, we make the first move and count 1, right? So we count after each move. 1, 2, 3, 4, 5. Just like a board game. I had a student that was really confused about this, about how to count them, and I was like, it's just like a board game. And I was explaining, how, if you're playing Monopoly or Trouble or whatever, you count after you move. Well, it turns out she didn't know that, and she'd been counting in board games wrong her entire life, and we laughed so hard about that because it was just ridiculous, like we just changed her life in this math lesson. Okay, example 5.4. I'm going to work over here so that we have our ladder in front of us. 5.4. Use directed numbers and the number line. No, use the ladder in the meadow to add plus 2 and plus 1. Okay, I'm not going to write out all the words this time. I just write them down. Oh, well, that's pretty easy. We start here, we go up 2, and then we go up 1 more. So that would be 3. Right? If you want to, some students like to write plus 3 just to make it super clear that they're in positive land. Whichever makes sense to you, do that. Example 5.5. This one, we want to add negative 2 and negative 1. Okay, we start at 0. We go down 2 and then down 1 more. Negative 3. And the last problem, I'll just squeeze in down here because I don't want to turn the page away from our beautiful artwork here. Use directed numbers and the number line, again, the ladder in the meadow, to add these numbers. And John writes out a fairly long expression. I'm going to grab myself some space so I can write it all out. Ready? He writes it like this. Minus 4. Oh, I forgot to go slow so that you guys could keep up. I'm really sorry. All right. Notice that each of these parentheses has a sign and a number inside of it, and they're all hooked together by plus signs. What that's telling us is that each one of these represents a move on the ladder. It tells us the direction and it tells us how many steps. The plus signs just hook it all together. Right? We're not going to use this format forever. This is just kind of a baby step that John's doing to help you get the hang of this. But we start at 0, same as always. This tells us to go down 4. All right, 1, 2, 3, 4. We're at negative 4. That sounds good. This tells us to go up 2. 1, 2. This tells us to go down 1 more, negative 3. And this tells us to go up 5. 1, 2, 3, 4, 5. So it looks like we end up at 2. Let's see if it's the right answer. Yay, it is. Let me put the plus in there just so you're sure. Okay, so we can use this with different kinds of instructions to climb up and down and combine these signed numbers. Eventually, you can, draw it out now. What I've basically done is just drawn a number line tipped on its side, right? Number lines usually go this way. I'm doing it this way so that you can imagine yourself moving up and down. And that is a picture that I want you to build into your head. I'm going to refer to this all the time. I'm going to say ladder in the meadow, and you'll know, oh yeah, the number line tipped on its side. So practice using it. Draw one for yourself for your homework. If you so, I want you to draw it. It doesn't have to be this fancy, because this is really fancy, you guys. I don't know if you, if you've got the really highly developed art skills to pull something like this off, but just do the best you can. Just kidding. Even if you just draw a number line like this and put 0 in the middle and then put a few positive numbers and a few negatives, so you can just practice going up and down. We won't do that for long. All this will be burned into your head. But for now, please play along with me. Simplifying some absolute values. Draw a number line for each of the following problems and use directed numbers. No. Draw one ladder in the meadow diagram and just refer to that as you're combining two numbers or all of those. Okay, lesson 5. Thank you. Goodbye. See you next time.